Hello everybody. So today we are going to start our next problem of lead code, that is the product of array except itself. So we are going to be given an array, and in that array we are going to find an output array that is going to have elements like, for example, 24, 12, 8, 6. If we go deep into the problem statement, for example, if we have this array here 1, 2, 3, 4, and we are at this element here, like this element 1, we are going to have the product at the index 1, which is this. That is, except for 1, we are going to have multiply all of the rest of the elements. For example, 2 multiplied by 3 multiplied by 4, that is 24, right? We're going to put 24 in here in the first place. So if we are in the second position, we're going to multiply all of the postfixes, prefix elements, and also the postfix elements. Like, for example, 1, 3, and 4, that is 12, and we're going to put back 12 in the second index. So we're going to find out the postfixes, the multiplicants of all of the elements except for the element itself, and put those results into the array and return that array back, right? So we have this problem. Let me just remove these elements from here. Hmm. So the problem is, um, the problem is relatively fairly simple, but we have this condition here that actually provides us a bit of a complexity here. So within this complexity, it says that we have to compute the answer in O of n time complexity, and also uh, without using the division operation as well. We don't want to use any division operation. For example, this problem would have been solved like this. For example, what we would have done was to simply compute this whole array, like that is 24, and then what we would have done was to divide each element by 24. For example, 24 divided by 1 is 24, right? 24 divided by 2 is 12. 24 divided by 3 is 8. So we could have solved this problem in relatively like often times complexity, and also this problem has restricted us for using the like the division operation. So we have another solution for this. Let's just go through it. I'm going to pick up this example 1, 2, 3, 4 array, and we're going to solve it from it. So what we're going to do simply, first step is we're going to like calculate the prefix, then we're going to calculate the postfix, and then what we're going to do is to calculate the results, right? Let me just reset this to 1. So what we're going to do is to consider the current like the prefix. Let me just write prefix here. We're going to consider the prefix as 1, as the current prefix, that is going to be 1. We're going to imagine like 1 is being present, an extra 1 integer is present for prefix, and an extra 1 integer is going to present for the postfix. For example, if are imaginary numbers in here, so to accommodate those imaginary numbers or the empty spaces, we're going to consider 1 for this. So what we're going to do, let's just iterate this and solve this problem. For example, let's say we're going to start with the prefix calculation. In the prefix calculation, we have 1 here and 1 here. We're going to 1 multiply 1 is equal to 1, right? We're going to add this into our prefix array, and our current prefix is still 1. Then we're going to multiply this 1, the prefix that we have added, with the 2. And now we have the prefix as 2, right? And we're going to change our current prefix variable with 2. Then 2 multiplied by 3 is equal to 6. We're going to write 6 here, right? And now we have the current prefix as 6. Now what we're going to do is 6 multiplied by 4 is equal to 24, right? We're going to add 24 here, and this is our last current prefix, so it doesn't matter. Like, we're going to proceed with the postfix now. In the postfix, what we're going to do is we're going to start from the backwards, because obviously this is a postfix. We're going to start from the reverse. And now I'm going to change the name of this. Let me just change the name to postfix here, and let me just rename it as 1, right? Now what we're going to do is to start from here. So 1 multiplied by 4 is equal to 4, right? We're going to add 4, and we're going to reverse it here. We're also going to reverse add these like numbers. So, and 4 multiplied by 3 is equal to 12, right? 12. We're going to add 12, and our current postfix is 12. 12 multiplied by 2 is equal to 24. We're going to add 24 here, and we're going to just simply copy this here as well. Keep track of the our current postfix. And 24 multiplied by 1 is equal to 24 again, right? 24. So this is going to be thing. Now, in the result section, what we're going to do, let me just change our highlights as well. Let me just write this down here. So, in the result, what we're going to do is, for example, we're going to iterate this array again, but now what we're going to do, for example, if we are on the number 1 here, right? Let me just change the width of this so you guys can actually see it properly. For example, we are at 1. Like, if we are at 1, we're going to consider the prefix to be multiplied with the postfix of this. For example, if we are on like 1 here, the prefix of this is going to be the imaginary number 1. The imaginary number 1 that is being considered. 1 multiplied by postfix, that is this. So this is going to be like this. For example, if we are considering this element here, we are going to consider the postfix, the prefix, sorry, to be multiplied by with the postfix. And it's going to have, for example, if this integer is going to be at first index, this has to be on the zeroth index. Let me just draw a stroke. Zeroth index. This is going to be on the zeroth index, and this is going to be on the second index. The postfix is going to be on the second index. I hope you get the whole, like the logic of this. If our element of the original array is considered the first index, then our prefix is going to be from the zeroth index. It can be an imaginary number, for example, 1, and our like postfix element is going to be the second one, right? So 1 multiplied by 24, that is going to be 24. Got it? Now let me just change the color. Uh, Sorry, let me just change the color back. 24. Okay. Now, let me just change the color again. This highlight, for example, we are on 2. In the second one, what we're going to have is we are going to be at the first element, this one, first multiplied by this one. So 1 multiplied by 12 is going to be 12, right? And now if we are actually on the third element, that is this one. So we are going to have like 2 here. We are going to consider 2 as the prefix, and 4 for the postfix, right? Let me just multiply these two, and we have 2 multiplied by 4, that is 8, right? And then we are going to have the final element, that is this one. So we have the prefix as 6. But if you look closely, we don't have any postfix, right? We don't have any because we have filled our already numbers. So we're going to consider an imaginary number, that is 1 again here. So 1 multiplied by 6, that is going to be 6. 24, 12, 8, and 6 is going to be the answer for this. So I hope you got the algorithm, that is the major crux of it. So now what we're going to do is we're going to further simplify the whole situation. We are going to eliminate these arrays because we are going to iterate. We're going to have an array now, that is, and we're going to iterate just 2 times. We don't have to store these elements. We don't have to store these like arrays separately. We can just use one array compute those answers and store the resultant array into it. I hope you get the answer. So, that's how we're going to proceed. But the original idea is going to be going to be remaining the same. So, what we're going to do now is to like, for example, if we're going to start from here again, like for example, 1 to 624, that is going to be the prefix, right? That is going to be calculated in the first time. In the second time, what we're going to do is to like um let me just show you what we're going to do again here. Let me just erase this down, because this time what we're going to do is to calculate this in like in two loops, but we're going to use only of and complexity, like space complexity. Let me just write this down. Okay, let me just empty this again. Okay. Okay, let me just empty this one again as well, right? So what we're going to do now is let's start with the multiplication. For example, we're going to start from here. 1 multiplied 1 is equal to 1, right? We're going to just add 1 as our prefix. And 1 multiplied 1 is going to be 1. So now what we have is 1 multiplied by 2 is going to be 2, and 2 multiplied by 3 is going to be 6. We're going to start from here, right? And we're going to start as the prefix here. Then what we're going to do is to start like multiplication from this here. For example, 1 multiplied by 6 is going to be 6. We're going to multiply the 1 with the prefix here. Because as I said before, we're going to use only one resultant array. We are not going to be using, this is going to be interchangeable. We're going to use the same array here. So now if we multiply 1 with the 6, 1, 6, this is going to be 6. And now if we consider we have the postfix as 4. Now, right, we have the postfix as 4. We have iterated from 6 here. We have this element now. 4. 4 multiplied by 2 is going to be 8. 4 multiplied by 2 is going to be 8. And now we have like the 3 here. Sorry, I've just written here 4. Let me just write 3 here. So if we multiply like so yeah, so we have the postfix as 4, right? So 4 multiplied by 2 is going to be 8. And after that, what we're going to do is multiply 4 with 3, that is 12, right? We have the postfix as 12. 12 multiplied by 1 is going to be 1. Sorry, 12, sorry. And now, finally, what we're going to do is to update the postfix again. 12 multiplied by 2 is going to be 24. And if we multiply 24 with 1 here, we're going to have 24 here. So I hope you get the algorithm. We are doing this because we want to save the space complexity as well. We're going to choose just one array, that is the resultant array, and we're going to modify it further and further. So let's start with the whole solution. So now what we're going to do is to write this here. Let me just write a resultant array. A resultant array is going to be the size of the length of the original array, obviously. And now what we're going to do is to have this variable as prefix, that where we actually going to store the prefix. Default value is going to be 1 as I shown earlier. And now for I in range length of nums, we're going to iterate this. And what we're going to do is to update this array. What we're going to do is to like in the section that I showed you earlier, what we're going to do is to one, we're going to set the prefix here, and that's how things are going to go. So let me just write it here. Result I equal to result multiply by equal to prefix, right? Prefix is going to be the multiplied result I, sorry, prefix, but now we're going to update the prefix. Prefix is going to be the multiplied multiple of the number, original number. Now we're going to, let me just copy this again because the mechanism is going to be the same for the postfix, but what we're going to do is to reverse this because we are going to start from the reverse, right? This is the decrementer. This is the index state we want to go. Now let me just set the postfix for this. Postfix is going to be equal to 1. And let me just write this as postfix. And let me just update the postfix again. Let me just return the resultant. And let me just confirm it one more time. Okay, so let's get back to solution. One thing we missed is -1. We need to add just -1 here to like to properly fixate the size. And now just let's just submit it out and let's see how the solution goes. So we have found our solution. So if you guys like this video, do subscribe to my channel and do like the video. And if you have any suggestions, do let me know. And would be looking forward to the next video, guys. So take care, guys. Have a great day.